So this is the second MYP4 probability video in this little series, and the first one ended with a bag containing 3 yellows, 2 blues and a red, counters, balls, whatever they happen to be. And we were considering the scenario where we pick one out but then we don't replace it before picking another one out. So because we didn't replace the first one, that affects the probability of getting red or yellow or blue on the second pick. So make sure you watch that first video first. And we did this tree diagram. By the way, with tree diagrams, little tip here, if you try to draw them from left to right, so starting at a point, drawing 3 out, and then drawing 3 out from each of those, you can get in a bit of a mess. You can get all the branches crashing into each other because it's difficult to judge how to space it. Much better way to draw these. You know it's going to end with 9 points, 3 times 3. So start off with 9 evenly spaced points and then just construct the whole thing from right to left. So draw it backwards, in other words. Anyway, moving on from what was in the first video, I'm going to think about the probability of getting exactly 1 yellow. Now, the problem with this is getting exactly 1 yellow can happen in a variety of ways. It can happen as red followed by yellow. It can happen as yellow followed by red, yellow followed by blue, or blue followed by yellow. So all of those are separate, distinct possible outcomes that can lead to you getting exactly 1 yellow. So because those are either or possibilities, we need to think about the probabilities of each of those and add them up. So the probability of getting exactly 1 yellow is 3/30ths plus 3/30ths plus 6/30ths plus 6/30ths. Those are the individual probabilities of all the possible ways that you could get exactly 1 yellow. And because you're wanting that one or that one or that one or that one to happen, because it's an either or situation, then you have to add them up. So it's quite complicated calculation because within each of these events you're multiplying, because for example here you want red and also yellow to happen. So when it's an and also probability, you're multiplying. But then these are either or situations. So you want that one or that one or that one or that one to happen. So you add them. So anyway, when you add them all up, you get 18/30ths. So there's an 18 out of 30 chance of getting exactly 1 yellow, no more, no less. Well, another situation you often face in questions is at least probabilities. What is the probability of getting at least 1 yellow? So at least 1 yellow can mean a yellow followed by one that's not a yellow, or starting with one that's not yellow followed by one that is yellow, or it could be just 2 yellows. So I've constructed this slightly simplified version of the tree diagram where things are either yellow or not yellow. So on the first pick there's a 3/6 chance of yellow because 3 out of the 6 balls are yellow, but then there's a 3 out of 6 chance of not yellow because 3 out of the 6 balls are not yellow. So Y dash means not yellow. Generally speaking, a dash like that is often used in probability to denote the probability of something not happening. Okay, so on the first pick, or after the first pick, and then on to the second pick, if you've picked yellow, then there are only 5 balls left in the bag, of which only 2 will be yellow and 3 will be not yellow. But if you didn't pick a yellow first, then there will still only be 5 balls left in the bag, but 3 of them will still be yellow, and 2 of them will be the non-yellows. So depending on whether you picked a yellow or not a yellow first, that will affect the probability of getting a yellow or not a yellow on the second pick, because it will affect the number of yellows out of the remaining 5 in the bag. So that's in a situation where we don't replace the balls without replacement. And looking at the tree diagram, the probability of 2 yellows, which is 6/30ths, the probability of a yellow first followed by a non-yellow, again multiply the branches out to get 9/30ths. The probability of a non-yellow first followed by a yellow comes to 9/30ths, just multiplying the individual branches, and the probability of 2 non-yellows is 6/30ths, again multiplying the branches. So the probability of getting at least 1 yellow. Well, one way you could look at it is just to add up the 3 different ways that could happen. So yellow, yellow, 6/30ths, yellow, not yellow, 9/30ths, and then not yellow followed by yellow, 9/30ths. Those are the 3 different ways you can get at least 1 yellow, and that comes to 24/30ths. But with more complicated questions, or if you were doing 3 picks instead of 2, that starts to get very complicated and involves a lot of calculation. So there is another way to approach this. You can say you're either going to get at least 1 yellow, or if you don't get at least 1 yellow, then you're going to get no yellows at all. And since all of the probabilities have got to add up to 1, you can say the probability of at least 1 yellow is 1 minus the probability of getting no yellows at all. Because one of those events is bound to happen. You're either going to get no yellows at all, or you're going to get at least 1 yellow. So because that covers all the possible events, it's got to add up to 1. So therefore, probability of at least 1 yellow is 1 minus the probability of no yellows at all. And that's easier to calculate, because then it's just 1 minus the single event, 6/30ths, where you get no yellows at all. So you can imagine if that was 3 picks you were doing, and therefore 8 branches, instead of having to add up 7 separate probabilities where you got at least 1 yellow, you're just doing 1 minus the single probability where you get no yellows at all. So doing 1 minus 6/30ths, you get 24/30ths, which was the answer we got before.